Hello and welcome, everyone. We'd like to thank you for joining us today. I'm going to go ahead and get started with our introductions as people continue to filter in here. Thank you all again for joining us. We will be discussing energy code basics today. So how do we actually use the IECC? We're going to kind of walk you through the code from front to back and discuss what is important and what isn't important in understanding how we actually use the code. Your presenters today are myself, Robert Schlorf, and my colleague, Ryan Siegel. The learning objectives for today's presentation are, we expect at the end of this presentation, you'll be able to navigate the layout of the 2021 IECC. You'll be able to communicate the scope and applicability of the energy code as it applies. You'll be able to identify the appropriate means of compliance documentation for each compliance pathway. So what do we actually need to present in order to comply with each different pathway? And then how can we apply IECC definitions to the prescriptive code language in order to better understand the requirements? So what are some of those key definitions contained within the code that help us to understand the actual code requirements? A couple other housekeeping points here real quickly. If you have a question for us, please use the Q&A button down at the bottom of your screen. Go ahead and pop your question in there anytime, and we will try to answer it on air either during the presentation or near the end of the presentation. You can use the chat box as well, but the Q&A box really puts it there forward for us so that we don't miss it. So please do that. Another note is that this webinar is being recorded. The slide deck as well as the presentation will be posted to our website after the presentation today for your future viewing. Who we are CDAC, the Smart Energy Design Assistance Center. Our mission is simply to reduce the energy footprint of Illinois and beyond. A little bit more about what we do. We are an applied research program at the University of Illinois, and our primary tasks are assisting buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. So we help facilities become more energy efficient. We educate, we research, and we advocate for a greener future for us all. Today's webinar is brought to you by the Illinois EPA Office of Energy. CDAC collaborates with the IEPA to provide code training and technical assistance for the Illinois Energy Conservation Code. So thank you, IEPA, for supporting this webinar. CDAC is also a preferred education provider with the International Code Council, the ICC, and this workshop is also approved for one LUHSW credit through the AIA. When you registered for this webinar, you had a chance to give us your AIA number or to identify whether or not you were part of ICC. If you gave us that information, we will submit your credits on your behalf. If you did not provide that information at the time of your registration, you can email us with that information and we will work out the credits and get them sent where they need to be. In terms of the credits for this course, we will send out credits at the completion of this course within a day or so. It usually takes us a little while to get those emails sent out, but you will receive an email at the end of within a couple days with a certificate of completion. We do have technical support for the energy code, as mentioned. We have a email, energycode@illinois.edu, where you can send any energy code questions, and that comes into our office and is seen by the whole energy code team. We also do have an 800 number listed there. If you have a quicker question that maybe can be answered by a pretty quick phone call, we do prefer that you send questions through the email, just simply because it lets everyone in the office get eyes on the question. We can come up with an answer together, and then we can provide you with a written response that might be a little bit more effective or easier to use than just something said over the phone. So you can use either method to contact us, but we do kind of prefer you using that email. Additionally, we have online resources available at our website, smartenergy.illinois.edu/energy-code. We have our previous workshops listed there with the slide decks and recordings, as well as our future webinars and workshops. We have those scheduled on our website. Additionally, we have online on-demand training modules. A lot of these training modules are geared more towards introduction, an intro level into the energy code, and they cover a range of topics, and those are free to access and free to use and on demand, so you can complete them on your own schedule. We do also have, our website also has a page with smart energy, with smart tips, which are kind of short, quick publications with quick energy efficiency tips. So our energy code training series for this for our coming year, today, energy code basics, and then we will continue on with existing residential buildings and residential stretch code before we get to December. Again, you can register for these upcoming webinars on our website. In-person workshops. We got back into in-person workshops last year and are looking forward to doing it again this year. Our first in-person workshop is still to be completely confirmed, but it is going to be in October and will be located in Springfield. We'll be again covering energy code basics, expanding on today's presentation with a little bit more content about simplifying code compliance and Q&A review. All right, the big question that is still a little bit up in the air, the 2021 Illinois Energy Conservation Code is still not effective, but will be coming soon. Our latest information from the Capital Development Board is that the 2021 Illinois Energy Conservation Code is on the agenda for the September JCAR meeting. Essentially what that means is that if there are no hiccups or further changes in this process, the code could be effective as early as October 1st. It is possible that that date might slide a little bit again in terms, there's a little bit of an overlap with the second open period for comments, but we do expect the earliest that the new code would be in effect would be October 1st. It could potentially slide a little bit again, but the process is nearly there. Oops. How do we access the IECC? The website listed there, codes.iccsafe.org, is the website that most of us here in the office use to quickly access the IECC. There are screenshots of code language within this presentation. Those screenshots come from this website, so you'll be seeing the code language exactly as you would as if you pulled up this website yourself. That's where you access the 2021 IECC. And then to access the Illinois amendments, at the moment, you need to look up the CDB board book from their May meeting and look for pages 26 through 69, and you will see the current list of amendments proposed for the 2021 Illinois Energy Conservation Code. Access to the Chicago Energy Transformation Code. So again, there's a link down there to the ICC Safe website where they have the Chicago Energy Transformation Code, the 2022 Chicago Energy Transformation Code listed in full, as they do with the 2021 IECC. And just a quick note that most of the content in this presentation will apply to the Chicago Energy Transformation Code, just as it does to the IECC. The organization of the codes is based on the same code. So most of this content will apply to both. Now I believe we have a quick poll question here just to see how well you all do know the code. How familiar are you with navigating the IECC? I know it's a book, I've looked through it, but have difficulty finding what I need. I'm familiar with navigating the code, or I'm a professional code navigator. So far, it's looking good. It seems like most people are at least familiar with navigating the code. So that means most of today may be a refresher, which we all need from time to time. Yeah, I'll go ahead and end the poll right there. All right. Yes, it looks like the vast majority of you are familiar with navigating the code. And then a slightly smaller chunk have looked through it, but have difficulty finding what I need. And then I know it's a book. And then actually the smallest percentage is I'm a professional code navigator. So hopefully we can all learn some things today. At this point, I'm going to pass it off to Ryan to start walking us through some navigation and language within the code.
Well, thank you, Robert. So with the IECC, it's broken into a few different chapters, which something that Robert had mentioned is the International Code Council does make all of their codes available on their website at no cost for people to view. So that's very, very useful. Another helpful thing is for a lot of what people are needing, the meat and potatoes, if you will, most people are familiar with Chapter 4 in the code. So being able to go through that, the search function actually works very well for the IECC. So you can go to the chapter that you're needing and do a word search and find and be able to quickly find wherever that word appears in the code. So that can be very helpful. And oftentimes is where we are. So being that most people are familiar with Chapter 4, and that's where a lot of the things are, I think that's part of what today's presentation is looking at, is saying, let's take a look at some of these other chapters as well. So these are it's 6 primary chapters, and then there's 3 appendices. Appendices are not part of the code itself. These are things that may be adopted by local jurisdictions and maybe supplements to the energy codes in whatever the particular jurisdiction here. And you'll notice throughout here we have commercial and residential. So like under appendices, you see there's a CA/RA. So there's 2 separate appendices, one for commercial, one for residential. So also, as we're going through here, understanding how the code is laid out it kind of is in a very tree format here. So we've got, whether you're in a C or an R for commercial or residential, then we've got the primary section numbers. So anything that begins, 400, 500, 300. So this being 402, this is going to be Chapter 4. So these are 3-digit numbers. It begins with the chapter number. So that's going to be our section number, then subsection, and then further subdivisions therein. So as we're going through this, anytime we start, so here on the right-hand side, we see we're starting in C402.5. So this provision is going to apply for anything that begins with 402.5. So further down, we see a 402.5.1. That's going to apply only to those, and then further down the tree. So it kind of starts from the top, and you're working your way all the way down the tree like that. So some other things is understanding code language. Code uses typically two forms. First is required language. Commonly, this is done as shall. So in this, the code shall be known. So that is, this is a requirement. This must be the way it is done. However, throughout much of it, you'll see the term may. So this is permissive language. Oftentimes, this is things where you may do it this way, you may do it that way. This is something you may do as you're going through this. And understanding as far as where to find things. So if we look back here, Chapter 1, this is just more administrative and what is the scope of this code as we're going through. Chapter 2 is definitions. So that is something that you will find is anytime you're looking for a definition of something, commonly in the code, if there is a word that is defined in the definitions, that's going to be found in italics within the code language. 3 is general requirements. This is where we're going to find mostly our climate maps, along with a few other provisions. And we'll touch on some of those other provisions beyond the climate zones And chapter 4, I mentioned, that's kind of where most of the new construction provisions are found. Chapter 5 deals in existing buildings. Oftentimes, chapter 5 will refer back to chapter 4, but it will, in essence, say, beginning with, here is what you do for an existing building, then go look at these subsections back in chapter 4. So it'll refer back as applicable for whatever you're doing with that. Chapter 6 is referenced standards. So if you come across something and it makes reference to an NFRC standard or an ASHRAE standard, Chapter 6 is where you can find what is the specific standard and standard version that is being referenced there. So it'll tell you the specific year of that code or standard that's being referenced. So as mentioned, chapter 2 is where you find definitions. As you're reading through, you won't find definitions within the provisions of the code itself. So being aware of that. And for those who may, as you're reading through code, you might find and say, you know, that could be worded better, or, hey, there's a provision that's missing, and you might be interested in providing a public input to the code making process, understanding that if you do have any definitions, that those have to be pulled out separate from whatever your provision is that you're doing that. So something as you're looking through definitions, being aware of is definitions may be located in places that you might not necessarily anticipate. So the IECC has tried to accommodate some of these. So you might think about, oh, I need to know what a below grade wall is. The IECC has predicted that. And so you see it's under below grade wall, it'll say see wall, comma, below grade. And so understanding with that, here we see two definitions for wall. So we've got wall above grade and wall below grade. So particularly understanding at what point does a wall become above grade versus below grade. So here for wall above grade, this is saying a wall associated with the building thermal envelope that is more than 15% above grade and is on the exterior of the building, or any wall associated with the building thermal envelope that is not on the exterior of the building. So interior walls would be above grade. And then it goes on. So here, looking at the definition, we're noting here for wall above grade, it has to be at least 15% above grade. If it's not, then we're dealing with walls below grade. So wall associated with basements or first stories that is not less than 85% below grade. So if you do have a walkout basement, you being aware of that 15% threshold, that's not a whole lot of that wall. So I mean, out of 8 feet, you know, if you've got more than about 1 foot exposed, that's probably an above grade wall. So being aware of some of these. Something else as you're reading, and this oftentimes can trip people up, is the code language does not use the Oxford comma. And so with that, you know, here we're highlighting in red, R values of insulation installed in or on ceilings, roofs, walls, foundations, and slabs, basement walls, crawl space walls, and floors, and ducts outside of conditioned spaces. So understanding that the code is not using the Oxford comma, crawl spaces, walls, and floors is one thing. Ducts outside conditioned spaces is another thing in here. So it can get a little tricky as you're going through here. Understanding that. So that's something we like to call out, is sometimes just the language of the code can be a little tricky. So also throughout here, as it's calling out, understanding, are we dealing with through and or. So the first section complying with 4021 through 4025, obviously that is fully inclusive. But when we look at the next one below, is complying with sections 40213, 40214, 40215, or C407. As we noted earlier, because they don't use the Oxford comma, these are four separate things. So it's either 40213 or 40214 or 40215 or 407. So being aware as you're reading through this and understanding some of these ors versus throughs and statements. So that's kind of just setting you up for how to actually read the physical language of the code. So looking at chapter 1, so this is kind of understanding where is this beginning from. So the scope of the energy code. So here, energy code applies to the buildings and the building sites, along with their associated equipment and systems. So it's not just the building itself. Could any affiliated parking lots, other ancillary structures, things like that. So it's the building and the building site inclusive. So obviously including detached garages, parking structures, anything that's on that building site, and understanding that the building site is the contiguous property attributed to the single entity owning that building. So it's kind of all encompassing there. As far as the intent, we're looking at design and construction of the buildings, and the key here is over the useful life of the building. So that's kind of where it's looking at it. The code is not looking at what is the first cost of things. It's looking at what is the cost over the useful life of the building. So if something has a longer lifespan, we're going to accommodate and account for those impacts over a longer period of time. The code does try to be flexible to allow for innovative designs. You will note throughout the code, it doesn't specify this is how you must do this. Typically, as far as actual construction and constructability of something, it doesn't specify these are the materials you must use. It talks about the attributes of materials. So for insulations, it'll talk about air permeability, because that's really what the more critical factor is. The actual type of insulation is less critical than its air permeance or impermeance. So the code does call out that it shall not abridge safety, health, or environmental requirements of other codes and local ordinances. So oftentimes, if you are going to have a likely safety concern, the code within the provisions will often call that out as an exception to a provision and call out, say, hey, this applies except in the cases of a particular safety hazard. So the code will recognize that when it's a common occurrence. But if you do have something where you have a very unique thing, that's where the authority having jurisdiction and having to make that case to that code official or the AHJ to say, hey, if I do this, that will cause a safety problem, and have them handle that. So, but typically we find that that's not a common issue. Commercial and residential. This is where the code is really kind of split in two pieces. You have commercial first in the code, residential second. And so understanding where you are in this. The IECC does have a split between these and calls out that for mixed use, commercial provisions apply to the commercial portions of the building, and residential applies to the residential portion of the buildings. Now, where this is understanding is residential construction as defined here in the state of Illinois is residential buildings, single and two family dwellings, along with multi-dwelling units where occupants reside predominantly on a permanent basis of 3 stories or less. So as we see on the left, that is a fully residential building. On the right, because we are over 3 stories, in particular, City of Chicago, you get 1 extra story for 4. So since we're even above 4 stories, regardless of where this is in the state, that is a commercial building on the right. So because we are above that 3 to 4 stories. So as far as our compliance process, understanding where that is, and part of the construction documents, making sure that all the pieces are in the construction documents when you submit them. So this obviously includes, how are we going to comply with this? Part of that is what information and materials should I be looking for? If I'm going to do a performance path, I'm not going to, I know to be checking for some sort of an energy model for that, or other documentation affiliated with that. Obviously, our insulation materials are critical. What are their air values? Any fenestration specifications? How did we design our mechanical systems? So what were the design criteria used, the temperatures therein, things like that? What's the capacity of the equipment and efficiencies, economizers? So as we can see, there's a fair bit here. Fan controls, duct locations and sealing, lighting fixtures, air barriers, thermal envelopes. So this is things you have to have in the construction documents through here. So here's what the lighting fixture schedule might look like, or this would be in addition to the schedule, but understanding what is your documentation. Here they're even calling out the fixture, the daylight zones. This is excellent process example of how to do this. We see here we have daylit zone 1 and 2, so our primary and secondary daylit zones, and then the interior zones. So it's kind of called out here. Does have a beginning of a legend. This is not a full fixture schedule here, but we do at least have a legend to help us read this documentation. As far as inspections, so these are the inspections that are called out in the code. We see here there are 6 separate inspections. Obviously, commonly there may be more inspections than 6, but some of these may also be combined together. So check with whoever the local inspection authority is, as far as how are they going to want to do your inspections, which of these are going to be done together, which of these are going to be separate. So they may be able to consolidate some of these rather than have you go through and do each inspection individually. So with that, I'm going to do one more poll question here. How does the IECC define an above grade wall? More than 15% of the wall for commercial and residential, 15% for commercial, 50% for residential, more than 50% for both commercial and residential, more than 50% for commercial and 15% for residential. We did have a question come in regarding residential provisions. Do we have for a 3-story building on top of a 1-story building? A 3-story residential on top of 1-story commercial, that is a 4-story building. And so if you're outside of the city of Chicago, that is a commercial building. If you're inside the city of Chicago, that's a residential building. So that is a little bit of a nuance there, being aware of that for that. So, but understanding that, so while the building and the building envelope may be commercial, there may be residential provisions that may apply for those residential portions. So just being aware of some of that. Also had a question come in regarding searching through the code. Once you've opened your code section, you can use Control F or find, and that will open a find window within your internet browser for that. Because yeah, if you just search the search bar at the top of the screen, that will search the entire thing for you. Question about basements, and do the basements count as stories? These are above grade stories, is how the building code counts for that. So, all right. How does the IECC define an above grade wall? This I will grant you, we did not cover this accurately, so this was a bit of a trick question. The correct answer is for commercial, because we touched on commercial. Commercial is 15%, residential is 50%. So that is something to be aware of. Is they do change the definitions depending on where you are. So I do apologize for not covering that correctly. As far as the second question, which of the following is not required to be included in the construction documentation for code compliance? That is the fourth one down, which is occupant sensing device control zones. It is good practice to put them in there, but the code does not require that. So we do have to have fenestration performance, economizer descriptions, equipment sizing, and our compliance path. So those are required. So with that, I'm going to turn it over to Robert to go into chapter 2, our definitions.
All right, thank you, Ryan. As Ryan said, we're going to move through into some definitions here, and we're not going to go through all of chapter 2. Obviously, there's a lot of definitions there, so we're going to pull out some of the more important ones and see if we can kind of quickly move through this and understand why these definitions are important. So first, some key building type definitions. So as Ryan described earlier, there is a difference between commercial and residential buildings within the code. If we are talking about specifically commercial buildings, there is then a difference between commercial buildings and commercial buildings that contain Group R occupancies. And so what is a Group R occupancy within the code? Group R occupancy is buildings or portions of buildings that contain any of the following occupancies as established in the IBC. That's Group R1, Group R2, or Group R4, where located more than 3 stories in height above grade plane, or as Ryan said, more than 4 stories in height above grade plane in Chicago. So why is this important? The insulation tables contained within chapter 4 have different columns with different requirements for Group R and all other groups. So if you have a project that has Group R within it, that the Group R portions of that building will have different insulation requirements than the non-Group R portions of the building, or a building that does not have any Group R within it would have different requirements than a building that does have Group R within it. So you want to make sure that you have that definition correct for your building. R3 is not included within that definition because for the most part, R3, Group R3 is single family residential or shorter than 3 stories. And so that would then be a residential building. Historic buildings. So we get lots of questions about historic buildings and how historic buildings interface with the energy code. The first thing to understand there is what makes a historic building. So the energy code defines this in 3 ways. A historic building can be listed or certified as eligible for listing by the state historic preservations officer or the keeper of the National Register of Historic Places. Second option, the building can be designated as historic under an applicable state or local law. And then the third option, the building can be certified as a contributing resource within a National Register listed state designated or locally designated historic district. If the building in your project fits any of those 3 definitions, it is then a historic building, and then it may then be exempt from the energy code requirements. If your building does not meet those definitions, it is an existing building, and you would then go to chapter 5 to see what requirements apply to your building. Moving on here, some key space definitions, not key building definitions, but key space definitions. So first, the definition of a building. This may be a little bit broader than you might expect. Any structure used or intended for supporting or sheltering any use or occupancy, including mechanical, surface water, and power systems on the building site and supporting the building. So as you can notice there, any use or occupancy. So this would include industrial uses. This would include a building used to house mechanical equipment. This is any structure used to support or shelter any use or occupancy. So that definition is fairly broad. There is an exemption within the code for low energy buildings. We've discussed this in previous webinars before. That threshold to meet the definition of a low energy building is pretty hard to meet for most buildings. That's 1 watt per square foot of energy use or no conditioned space. So otherwise, if it's a building, if it's a structure used for any use as stated in the definition there, the code will apply to that building. So no conditioned space, as I just said. So what is conditioned space? Well, conditioned space is an area, room, or space within a building thermal envelope and directly or indirectly heated or cooled. So the building's thermal envelope is where we have our 4 control layers: water, air, thermal, and vapor. That's represented in the diagram there off to the right. That red line is representing that building's thermal envelope. So that's where the water, air, thermal, and vapor control layers are contained within this building. Anything within that red line is considered conditioned space. One of the reasons why this definition is important is that it says indirectly or directly or indirectly heated or cooled. So where this might come into play is if you have a space like a sunroom or a 4-season porch that is connected to the rest of a house, say. That sunroom may not have vents from the HVAC system. It may not be directly conditioned, but unless there is a full separation between that space and the rest of the house, a full exterior door, full insulation, exterior walls, that space is being indirectly heated or cooled. So that's where that definition comes into play. And then lastly here, greenhouses. The only reason that we bring this up is just to point out that the code does treat greenhouses specifically as their own entity. It recognizes that a greenhouse is a structure or thermally isolated area meant primarily for the cultivation of plants, and it must be built and exist for at least 180 days. So we're not talking about a temporary structure there. We're talking about something that is a permanent structure. Oops. Moving on here, so dwelling or sleeping units. So these definitions are contained within the code, and our point in bringing these up here to show that these two things are very, very similar, but they are distinct and different and have distinct and different requirements within the code. So a dwelling unit is a single unit providing complete independent living facilities for 1 or more occupants, including permanent living, sleeping, eating, cooking, and sanitation. So the floor plan shown there off to the right is a sample floor plan of an accessory dwelling unit that comes from the city of Del Mar in California. This is an example of exactly what a dwelling unit is. That is the definition of a dwelling unit. All of the pieces that are needed are there. A sleeping unit is very similar. However, a sleeping unit is differentiated by the sanitation and kitchen facilities. So a room or space in which occupants sleep that can include permanent provisions for living, eating, and either sanitation or kitchen facilities. So a sleeping unit cannot contain both sanitation and kitchen facilities. So where this might come into play, if you have a multi-unit building, a multi-family building that has cooking facilities, or actually, so let's do this, multi-family, multi-unit building that has sanitation facilities within their units. So each unit has its own bathroom, but the cooking facilities are shared per floor. Those units would be sleeping units and not dwelling units. So again, these two things are very similar, but they are different, and there are different requirements throughout the code that refer to either dwelling or sleeping units. So just keep in mind that some things may seem similar, but they may be different and have different requirements. Moving on to a few more key assembly definitions. So a little bit of a recap from what Ryan discussed earlier. Walls above grade, if we're talking commercially, that's more than 15% above grade. It's more than 50% for residential. Below grade is 85% or more below grade for commercial, 50% again for residential. A low sloped roof. So a low slope roof is a roof having a slope of less than 2 vertical units per 12 horizontal units. There is no such thing as a flat roof in reality. Anything that is referred to as a flat roof is actually a low sloped roof. So there is no flat roof definition within the code. Vertical fenestration. So vertical fenestration is another term for windows. So what makes a window? A window is a fixed or operable glazed openings or glass block that's oriented more than 60 degrees from horizontal. So if it's more than 60 degrees from horizontal, that is now a window. What happens if it's less than 60 degrees from horizontal? That is now a skylight. And there are, again, different requirements for both vertical fenestration and skylights. That's why there are different definitions. Okay, some key fenestration definitions. We're going to kind of go through these a little bit quickly and not dive into the details of all of these. These will come into play whenever you're looking at window performance. So U factors is thermal transmittance through the window assembly. Oftentimes, U factor is referred to as the inverse of R value, which in all practical senses, this is true. But U factor does take a couple other things into account that R values don't. So U factor actually includes conduction and radiation from materials, whereas R value is simply the resistance to heat transfer through a material. So a U factor in terms of a window, a low U factor is going to represent high thermal resistance. So that's going to be a lower U factor is a better performing, more efficient window. Solar heat gain coefficient, or SHGC. This is the ratio of solar heat gain entering the space through the window assembly compared to the incident solar radiation. So solar heat gain includes directly transmitted solar heat and absorbed solar radiation that is then re-radiated, conducted, or convected into the space. This breaks down to solar heat gain coefficient represents how much heat from the sun the windows allow to pass into the building. A high SHGC means more heat is entering the space from the sun, from sunlight. A low SHGC means less heat is entering the space from sunlight. Visible transmittance is the amount of visible light through the window. So this breaks down essentially as a high VT equals more light is entering the space through the window. A low VT would mean less light is entering the space through the window. What this is primarily used to control is daylighting and glare control. So you can specify your window visible transmittance to meet your daylighting and glare control needs, depending on where your building's located, where those windows are facing. These values, these performance indicators for fenestration will come into play when you're selecting windows and specifying windows, and also in one portion of Chapter 3, which I will get to here in just a little bit. Speaking of Chapter 3, we'll go ahead and jump in. So Chapter 3 contains general requirements. So we're going to go ahead and walk through a few of those now. The first general requirement is the climate zone map. This is contained in section C or R 301. This is a map of the United States that shows each county and then has a color-coded legend for climate zones. You can see the climate zones are arranged from 1 through 7, actually 8 even, up when we get up into the subarctic and Alaska. So 1 through 7 kind of represents 1 as hot, or 8 is very cold, and then there's also 3 moisture regions, which are marine along the west coast, dry, and then moist. This is where you go to figure out what are the climatic conditions I need to pay attention to in order to design my building properly. The best buildings are designed to match the conditions of their site. And so this starts you off on the path of saying, okay, we're located here. These are the climatic conditions for my site. If the map is hard to read, or you'd rather read this in text, there is a list of climate zone designations by state and county located in table C or R 301.1. So this information is also included in text within the code. Okay, R and C 302 design conditions. So these are interior design conditions that are to be assumed values to be used for heating and cooling load calculations when other information isn't available or isn't quite known yet. Another way to look at this is that this is the maximum and minimum design points that the code would like us to use to determine heating and cooling loads. In terms of designing your systems, you need to set the maximum for heating at 72 degrees and then a minimum for cooling at 75 degrees. Going cooler than that on cooling or going warmer than that on heating is not allowed within the code in terms of designing your systems. This may come into play if you are following the performance paths or the energy rating index path for residential projects. Both of those paths would require you building an energy model that would have inputs for thermostat set points, and that's where these values could come into play. Move Moving on, so section 303, thermal envelope product identification. This section basically lays out the points of verification that exist in order to determine that the insulation that we've specified and designed is actually installed correctly and is installed per design. So first, we must use insulation products that have a visible label, a certificate or a certificate stating the R value, and that is the actual R value. So you need to keep track of that information when you're on site. Another point here is blown attic insulation must have markers placed every 300 square feet. The photo to the right there shows an example of those markers. And if anyone's been up in an attic, you may have seen that before. These markers need to be oriented to the attic access and need to indicate the insulation and depth. Now, a quick note, if you happen to be one of the people checking on those markers, you may want to dig down to the insulation and make sure that the bottom of the marker is actually where it should be. But that is one key indicator to make sure that we have enough insulation within our attics. Labels and markers must be readily visible during inspections. Fenestration products must have an NFRC 100 label or certification. Garage doors can also be certified by ANSI DASMA 105. And then insulated siding shall be determined by ASTM-C 1363. Okay, so we talked a little bit about fenestration definitions, key performance indicators, where those might come into play here. There is a section 303.1.3 with default fenestration, U factors, SHGC, and VT values. So when these would be used are if on a project you have windows that do not have an NFRC 100 label or certification, you must then use these values. The code is basically saying, okay, your windows are not certified or labeled with the correct label. We can't necessarily verify their performance. So we're going to assume that their performance matches the values within these tables. If you actually look at the values in these tables and compare with the values that are contained in Chapter 4, these tables heavily penalize window performance. So basically what this means is that if you are forced to use these default fenestration values, you will be most likely forced into a pretty difficult UA trade-offs or going down the performance path in order to meet overall envelope performance. These windows really are kind of the worst possible windows you could buy. So moving on from that, installation requirements. So there's a couple other notes about insulation and how we protect it. So foundation insulation must be protected by a rigid, opaque, and weather-resistant covering. The covering shall extend at least 6 inches below finished grade. The detail off to the right there shows a note that points out protection board or panel on the outside of that foundation insulation. That is a very important thing to make sure that insulation does not get degraded or damaged in any way. And then the next point there is for insulation board installed in 2 or more layers, either the manufacturer's specific instructions should be followed or lacking instructions, the board shall have staggered edge joints. This just means that we want to layer 2 layers of insulation so that none of the joints are right directly on top of each other. All right, I believe we now have another poll question. All right. Next poll question is, which is true of the default fenestration values assumed in Chapter 3? They closely align with industry standards, but don't quite meet the code. They heavily penalize window performance and should be avoided. They are close to window performance required for climate zone 3, or they are an average of the required performance for each climate zone. Which chapter of the IECC contains the climate zone definitions? Chapter 1, Chapter 2, Chapter 3, Chapter 4, or Chapter 5?
All right, a few more questions that have come in. Will reviewers look at both the drawings and the specs for information, or does all the information need to be in the drawings? It does need to be in the construction documents. So that includes both the drawings and the specs. Best practice is if you can have a table of values as far as here is where you find each of these, that will make your plan review go much quicker. And something that I've heard before and I really like is say it once and say it right. So that by having just that cross-reference table, you know exactly where you can go to find that information and quickly get to it. So okay. Either is acceptable.
And go ahead and end the poll here to keep us moving along. So the answer to the first question looks like everybody got that one right, which is true of the default fenestration values assumed in Chapter 3. They heavily penalize window performance and should be avoided. And then which chapter of the IECC contains the climate zone definitions? Looks like almost everybody got that one right as well. Chapter 3. All right. Stop sharing here and hand it over to Ryan to start walking us through Chapter 4.
All right. So Chapter 4, this is where most people are going to be familiar with as far as the actual requirements. So first mentioning about the layout. So you'll see commercial is on the left-hand side of the screen, residential is on the right-hand side. We still go in the same order, building envelope, then the mechanical, service water heating. So service water heating and mechanical are combined in residential systems. Then we do lighting and power. And then this is where it kind of deviates, where we've got the commercial, you get additional efficiency requirements, then total building performance. So total building performance, that is if you're doing the performance path, where you want to prove that the annual utility cost will be less in your proposed design than a code minimum building. And C also has 408 maintenance and commissioning. So, whereas on the residential side, once we've gotten through envelope systems, lighting and power, here we've got the total building performance. So again, that performance standard energy rating index, which is similar to the HERS rating, but a little bit different. And then we've got tropical climate and then additional efficiency package options. So here, residential, they put the additional efficiency way at the end, where commercial, they put it right after the power and lighting systems. So as far as compliance paths, this is where we get a lot of questions about prescriptive. So we've got prescriptive versus performance. Prescriptive is kind of like your shop. You get your grocery list and you got to make sure you check off and get every item on that list. So it's prescriptive is a little less flexible. And something to be aware of is with UA trade-offs, that is still prescriptive. UA trade-off that's commonly done through either ResCheck or ComCheck, that is still the prescriptive path, and all the prescriptive requirements would still remain. All the UA trade-off is kind of allowing you to do is if I want to put in better windows, then I don't need as much insulation in the walls or roofs, or vice versa. So I'm gonna trade a little bit within the envelope. So again, ERI mentioned that as residential only. And so commonly that's going to be done by someone who oftentimes is a HERS rater, but not necessarily required for that. So mention prescriptive path. Again, this is where ComCheck, ResCheck come into play. Again, this is typically the UA trade-off for that. Also, something else that we do call out, if you might check with your jurisdiction to see if they have any particular prescriptive compliance forms. The International Code Council did develop a checklist form that you can use, but that's not necessarily used by all jurisdictions. So go ahead and ask your jurisdiction if they have any particular forms or things that they wish to have you use for that. Again, the easier you make it for the jurisdiction, oftentimes I find the easier they're going to make it on you too. So performance path. So this is where you have to do energy modeling. So this is where you're going to design two models. One is what I'm actually going to propose for my design, and the other is going to be a similar building built to the code minimum standards, and oftentimes comparing either the energy intensity or the energy cost of those, depending on which path you're using for that. That is something for any jurisdictions coming up that are going to be using the stretch code. Those are based on the energy intensity and not the energy cost. And so part of that is recognizing that there is a dramatically different there's a dramatic difference in unit cost of energy between electricity and fossil fuel and other fossil fuels. So with that, trying to not take advantage of that dramatic difference for that. So as far as if you are going to use software, there's several softwares here shown on the screen. As far as eQuest, Energy Plus, and several others, they all have these different software requirements. Obviously we need to be able to model an entire year. It has to have climate data built in and the like. So there's a lot of requirements for these. But understanding this is where this is going to be for a commercial total building performance methodology for that. ERI, so here we're switching from commercial on the left, we're going over to residential on the right. So these are going to need to be ResNet or ICC 301 approved. So there's a few different ones out there. Again, oftentimes these are going to be done by HERS ratings or HERS raters through the ResNet, because the ERI and the HERS rating are very, very similar, and they're actually based on the same standard protocol. So something that'll be new for Illinois, as Robert mentioned, hopefully coming here shortly. If all goes well, it'll be available beginning October 1st, is for those people doing residential buildings who may wish to use the passive house standard. There is now a new FIAS compliance options. All the compliances for these is as part of your initial permitting submittal. Not only would you provide your construction documents, but you would then provide these two items of a list of compliance features and the pre-certification letter for FIAS. And then for the finals, you're just providing your FIAS 2021 or later project certificate. You don't have to do any other res checks. You don't have to do anything else. So that makes compliance real simple for these. Part of this is recognizing passive house is a very high standard, and so you're going to end up with a high performance building. Plus, as going through this, you already have third-party verifications and inspections throughout this process. So that's part of the reason why the documentation for FIAS is relatively minimal on this. Again, kind of understanding where our building area is. There's similar definitions as far as, where is the roof area, wall area versus fenestration. A common issue we do run into for res check or comp check is when you do the wall area, you go ahead and include the entire wall area, and similar for the roof. You don't remove any of the fenestration from your calculation. Comp check and res check will already do that math for you. So if you have a total of 1,000 square feet of wall and 200 square feet of fenestration, you're going to go ahead and put 1,000 feet of wall, 200 feet of fenestration, and it will calculate and say, okay, 800 square feet of opaque, 200 square feet of fenestration for you. So reason why this gets into understanding where you are is these requirements here. So we're going to just take a quick look at ground floor wall insulations. So if you're in the commercial side, again, it depends on if you're above grade or below grade. Are you in group R or non-group R? So even if you're in institutional, which oftentimes, a lot of times the codes may group R and group I together because they have some similarities as far as we've got occupants there all the time. But here they do separate that out. It's just group R and everything else. We see if we take a look here below grade for it's either 7.5 continuous or 10 continuous. If we look over at residential below grade, we're looking at R15 continuous, or it does have an option if you wish to not do as much continuous, that you can do R19 cavity or 13 cavity plus a 5 continuous on the outside. So it does give you a little bit more flexibility on the residential side as compared to the commercial side, gives you a few more options. Something to be cognizant of as you're going through this is watching out for moisture, particularly for below grade. So just touching on Chapter 5 real briefly. For Chapter 5, in general, new assemblies have to meet requirements for new construction. But obviously, overall building efficiency cannot be reduced after versus where you started. Existing cavities that open or are exposed as part of that are part of the exterior envelope need to be insulated. All you have to do is fill the cavity. You don't have to fur it out or anything like that. And your new work must not create unsafe conditions. So really what Chapter 5 touches on often is you have to do the best you can within the constraints that you are given. So that's why it calls out that, hey, if you open a cavity, just put the insulation in, fill it with insulation, and that's all you need for code compliance. Even if you can't put your R30 insulation in the wall, as long as it's a full cavity of insulation, you're good. So, and then Chapter 6, this is where we get into all the reference standards. So we had touched earlier on NFRC. So if you're needing a particular standard, how do I know if this was rated properly? So the code is based on, here we see NFRC 100, the 2020 version of that. So being aware is part of that. So with that, we have one more poll. And that is, how is Chapter 4 organized? Insulation, lighting, power, HVAC. HVAC, insulation, lighting, and power. Insulation, HVAC, lighting, and power. Lighting and power, HVAC, or insulation. Second question, which is not a core tenet of Chapter 5 for existing buildings? Improve as much as possible given any constraints. Altered systems cannot perform worse than existing systems. Altered systems cannot overload the existing systems or create unsafe conditions. Any change to existing building must fully comply with the current energy code requirements.
All right. We did have a question come in. If you are doing interior remodeling only, how does ResCheck or ComCheck work? Really, that is not an ideal situation to use ResCheck or ComCheck. That program really will not serve you very well in terms of a remodeling, project.
Yeah, for interior remodeling only, again, yeah, ResCheck and ComCheck, those are designed for predominantly envelope projects. If you have just interior remodeling, Chapter 5 is likely going to, you're going to likely just be doing prescriptive compliance, which is predominantly, okay, my lighting systems are going to comply with whatever the requirements are and the like. So yeah, if it's just an interior facelift, probably what you're going to end up with is just, it's going to be prescriptive compliance. You're not going to do a ResCheck or ComCheck for that.
Mm-hmm.
With that, let's go ahead and end our poll. All right, most people did pick it up here. So Chapter 4 is organized. We start with insulation, then HVAC, and finally lighting and power. And for question number 2, which is not the core tenet of Chapter 5, that is the last one. Any change must fully meet the current energy code requirements. Again, kind of like with our cavity insulation, just fill your cavity. your goal is to try to make improvements within the existing constraints. So, okay. Car washes. How do car washes deal with the 2021 code? That may depend on if it is designed for human occupancy. Car washes may there may be a little piece of the car wash that is oftentimes I've seen car washes, they'll have a little office area or something like that. That area needs to be done in compliance, but the actual wash bay itself that the cars are driving through, typically those would not be included as part of your energy code compliance checks. Right. Part of that is they're going to probably be more insulated for freeze protection than actual people.
Right. I was thinking they'd probably go back to the definition of conditioned space. Do those tunnels contain conditioned space? If they do, you may have some compliance requirements there. If they don't, you probably don't. But as Ryan said, you're probably going to be insulating more for freeze protection than anything else in that case.
Yep. Okay. Someone else pointed out that there's a good, we had given an example earlier of sleeping units that had bathrooms in each of them, but a shared kitchen. The converse could be true. So this could be like a residence hall or dormitory where you've got a shared bathroom, but you might have cooking equipment in the units. So
yes, that's a good example.
Yep.
And I'm about to post the link for the checklist again.
Yep. And again, an archived copy of the recording of this webinar, along with the slide deck, will be made available on our website following today's presentation. Again, if you have any other questions or think of anything afterwards, again, reach out to us, energycode@illinois.edu. I want to thank everyone for joining us today. You have a wonderful afternoon.